Hello everyone and welcome to the Proactive Learning YouTube channel. Today we're going to go through paper 1, non-calculator of the GCSE higher tier. So let's get started. So question 1 says work out 6.3 times 2.4. So the first thing we want to do is ignore the decimal place. So instead, let's find out what 63 times 24 actually is. To do that, we do the classic multiplication method. 63 times by 24 like this. 4 times 3 is 12. 6 times 4 is 24 plus 1 is 25. Add a 0 there. Then 3 times 2 is 6. 6 times 2 is 12. And then we add these numbers together. So 2 plus 0 is 2. 6 plus 5 is 11. 2 plus 2 is 4. Plus 1 is 5. And then we have a 1 on its own there. But now, how do we take into account the decimal places? To do so, we look at the numbers themselves. So 6.3 and 2.4. 6.3 has one decimal place. 2.4 has one decimal place. So in total, we have two decimal places. So we use two decimal places here. One decimal place, two decimal places. So then our final answer is 15.12. which we write on the dotted line. So 15.12. Moving on to question 2 now. Question 2, part A, says, write down the value of 5 to the power 0. Now, a fact we should have learnt in school is that anything to the power 0 is equal to 1. So 5 to the power 0 is also equal to 1. Then, in the second part of part A, it says, write down the value of 5 to the power negative 2. So, when we have a negative power, what we do is put 1 over that power. So 5 to the power negative 2 is equal to 1 over 5 squared. We know what 5 squared is. 5 squared is 5 times 5, which is 25. So then we can write it as 1 over 25. And that is the value of 5 to the power negative 2. For part B now, part B says, write this following fraction in the form 2 to the power n, where n is an integer. So the first thing we want to do is simplify the fraction. Let's first look at the numerator. So we have 2 to the power 5 times by 2 to the power 4. Since we have the same base number here of 2, all we need to do here is add the powers. So we have a power of 5 and we have a power of 4. 5 plus 4 is 9. So this is the same as writing 2 to the power 9. So then, if we include the denominator now, we have 2 to the power 9 divided by 2 to the power 3. Same sort of method here, since we have the same base number of 2. When we divide, we subtract the powers. So then we have 2 to the power 9 minus 3, which is the same as 2 to the power 6. And that would be our final answer there. And to just double check, we have an integer as our power, which is 6, so it makes sense. Moving on to question 3, part A now. Part A asks, write 156 as a product of its prime factors. To do that, what we can start by doing is seeing how can we split 156 into smaller numbers. The first thing we can sort of notice is 156 is an even number. So we know we can divide it by 2. So if we divide 156 by 2, we get 78 and 2. Now in this case, 78 is also an even number, so we can split that into 2 and another number as well. So 78 divided by 2 now is 39. And then last but not least, 39, we can recognize that it's divisible by 3. So then we can split apart 39 by 3 and 13. And last but not least, we've been left with 1, 2, a second 2, 3, and 13. So here we have the prime numbers where if you multiply them together, we get 156. But how do we write this as a product of its prime factors? To do so, we write it like this. So we have 2 times 2 times 3 times 13. But here we have 2 lots of that 2. So we can write it as 2 squared times 3 times 13, and then we write it on the dotted line. So 2 squared times 3 times 13. But now in part B now says, find the highest common factor of 156 and 130. So we know 156 can be written as 2 squared times 3 times 13. So let's find the product of primes for now 130. So 130 is an even number, so similar to part A, we can write 2, and then 130 divided by 2 is 65. 65 can be split into 12. Not 12, 13 and 5. And from here, we now have the prime numbers, where if you times them together, you get 130. So 2, 5, and 13. So then we can now write 130 is equal to 2 times by 5 times by 13. But now, how do we find the highest common factor? So immediately, what might come to mind is we see a 13 and a 13. So immediately we're thinking, okay, 13 might be the highest common factor. But the only thing here is there's something else in common. Each of them have at least 1 2. So the highest common factor would be 13 times by one of these 2's, which is equal to 26. So the highest common factor of 156 and 130 is 26. Moving on to question 4 now. Part A says, the mean length of 5 sticks is 4.2 centimeters. Narwhal measures the length of one of the sticks as 7 centimeters. Work out the mean length of the other 4 sticks. So, the first thing we need to do is think about why has the examiner given us these details. So the first thing is, we've been told what the mean is and the number of sticks that's been measured. So to find the mean, what we do is we find out the total of whatever it is, in this case the length, and we divide it by the total number of things there are. In this case there's 5 sticks, and the mean is equal to 4.2. So here, what we can do to find the total length is do the opposite, times both sides by 5. So then our total length of all 5 sticks is equal to 4.2 times by 5. So now, it's a non-calculator paper, so we can't just put this into our calculator, but we could do it in a slightly easier way. We can write it as 4 times 5 and then 0.2 times 5. 4 times 5 is 20, 0.2 times 5 is 1, so the total is 21. But now, the total is 21 centimeters, but we've been told to find the mean of the other 4 sticks. So we have to take 21, subtract 7 from it, so that gets us 14 centimeters. So the total now is 14, and we're dividing it by 4 sticks now, which is the same as 7 over 2. So then we can say our mean is now 3.5 or 7 over 2. Moving on to part B now. Part B now says, Narwhal made a mistake. The stick is no longer 7 centimeters long, it's 17. How does that affect our answer? So in part A, we took the total length and we subtracted 7. But here, instead of doing 21 take away 7, we're doing 21 take away 17. So the number that we now have as our total is smaller. So that means if our total is smaller, our mean is going to be smaller as well. So we can say our correct mean is smaller. Now we can actually calculate it. So 21 take away 7 was 14, but 21 take away 17 is 4. So if we do 4 divided by 4, then the mean would be 1 centimeters instead of 3.5, showing that we're correct. Moving on to question 5 now. Question 5 says, the point P lies on the line AB. Use your ruler and compasses to construct an angle of 90 degrees. In other words, a perpendicular bisector. You must show all of your construction lines. So the key thing with this question here is you want to get your compass and you want to put one end of it firmly on the point A. And make sure that your compass is at least halfway along the line AB. Then you want to draw the arc of your compass and do exactly the same thing with the same length for part or point B. Now, after you do this, you're left with something along the lines of this, some sort of arc on both sides, and where these arcs intersect, you can draw a straight line. And then it gives you a perpendicular bisector or a 90-degree angle between the line you've drawn and the line AB. Looking at question 6 now, question 6 tells us the diagram shows an isosceles triangle ABD and the straight line ABC. Then we're told BA is equal to BD, X ratio Y is equal to 2 ratio 1, work out the value of W. So here, the first thing that comes to mind is the term isosceles triangle. Now what we know is the two base angles of an isosceles triangle are the same. So we can label BDA as X degrees, similar to BAD. Now from here, the next thing that we need to look at is what this ratio means. So the ratio X to Y being 2 to 1, all that means is our angle X is equal to 2 lots of our angle Y. So if this is the case, this angle here is the same as a half X. But then you could also write it in a different way. Instead of introducing fractions, the angle X is equal to 2Y, similar with this angle here, 2Y. Now something we know about triangles is all of their angles add up to 180 degrees. So we have 3 angles now. We have an angle labeled Y, we can add another angle labeled 2Y, and we can add a third angle labeled 2Y again. And that has to be equal to 180 degrees. From here, we've got 2 lots of a Y, 2 lots of a Y, and 1 lot of a Y. So we can write it as 5Y, and that's equal to 180 degrees. From here, Y is now equal to 180 divided by 5. Now 180 divided by 5 gets us 36 degrees. So that's what Y is equal to. But we don't want to know what Y is equal to, we want to know what the angle W is equal to. Now remember, a straight line has an angle of 180 degrees. So we can then write W is equal to 180 take away Y, which is the same as 180 take away 36, which is the same as 144 degrees. And that would be our final answer. So W is equal to 144 degrees. Question 7 tells us, Mano has 3 shelves of books. There are X books on shelf A, there are 3X plus 1 books on shelf B, and there are 2X minus 5 books on shelf C. There's a total of 44 books on the 3 shelves. All of the books have the same mass, and the books on shelf B have a total mass of 7,500 grams. Work out the total mass of books on shelf A. So the first thing we want to figure out when it comes to shelf A is how many books are on shelf A, number-wise. So to do that, what we need to do is add up all of the books on all of the shelves, because we know it equals 44. So let's do that. So we have X books on shelf A, and we want to add 3X plus 1 books on shelf B, and we want to also add 2X minus 5 books on shelf C. And all of this equals 44. But now we can simplify the left-hand side. We've got 1 lot of X, 3 lots of X, and 2 lots of X. So that adds up to 6X. Then we have plus 1 and minus 5. 1 minus 5 is the same as negative 4. And that is equal to 44. From here, what's the opposite of taking away 4? It's adding 4, isn't it? So let's add 4 to both sides. So then we have 6X is equal to 48. From here, the opposite of timesing by 6 is dividing by 6. So divide 6 on both sides. So then we get X is equal to 8. So in other words, when x is equal to 8, we know now that there are 8 books on shelf A. So now we know that how many books there are on shelf A, but we don't know how much each book weighs or the mass of each book. So then we need to look back at another detail. We're told that the books on shelf B have a total mass of 7,500 grams. But how many books are there on shelf B? 3x plus 1 books. But we know x is equal to 8. So then 3 times 8 is 24 plus 1. So that is equal to 25. So in other words, there's 25 books on shelf B that have a mass of 7,500 grams. So to find out how much each book weighs, we need to do 7,500 divided by 25. To do that, think about this simply. So how many lots of 25 goes into 75? And that's 3. Then you add 2 zeros to it, so 300 lots of 25 goes into 7,500. So in other words, each book weighs 300 grams. And since there are 8 books that each weigh 300 grams, 8 times 300 is equal to 2,400 grams. So the mass of the books on shelf A is equal to 2,400 grams. Looking at question 8 now, question 8 says the normal price of a mattress is reduced by 40% in a sale. The price of the mattress in the sale is £660. Work out the normal price of the mattress. So we have the original price of the mattress, and then it's reduced by 40%, which then becomes £660. But we want to work out what the normal price of the mattress was. So the first thing we want to do is figure out, what do you need to times by to reduce the price by 40%? So you can times it by 0.6, can't you? But to go back, the opposite of timesing by 0.6 is dividing by 0.6. So what you can then do is divide by 0.6. But here, that might be slightly difficult because we don't have a calculator. So what other way could we do this? Another way we could do this is think that 60% of the original price is 660. So in other words, could we find out what 10% is? So to go from 60% to 10%, we divide by 6, don't we? So if we divide 660 by 6, that gets us 110. So in other words, 10% of the original price is £110. But we don't want 10% of the original price. We want the original price on its own, so 100% of it. So from there, we times by 10. And if we times by 10, we get 1,100. And as a result of this, we now have the normal price of the mattress, which is £1,100. Looking at question 9 now. Question 9 says, to cook rice, the number of cups of rice, X, in a ratio where the number of cups of water, Y, is equal to the ratio 4 to 5. Use this information to draw a graph to show the relationship between the number of cups of rice and the number of cups of water needed to cook rice. So here we're given a sort of X and Y axis for us to draw a graph. The first thing that we need to think about here is, when it comes to drawing a graph, we need to think about the equation of a straight line. So y is equal to mx plus c. Now here, we can first look at the gradient, can't we? So the gradient, in other words, is the rise over the run. In this case, we can look at it in terms of x and y. So here, our rise is 5 or 5 cups of water. And our run is the number of cups of rice, in other words, 4. So our gradient is 5 over 4. So what we know here is our gradient is positive. So we're looking at a direction along here somewhat. The next thing that we want to think about is, what would the y-intercept be? So when there are 0 cups of rice, we don't need any cups of water, do we? So then our y-intercept is 0. So as a result of this, our line would look something like this. So we would go 4 along, and then we would go 5 up, wouldn't we? So we would go somewhere there. Then we do exactly the same thing again. 5 along, or 4 along, and then 5 up. So then our line would look something like this. So that would be our line. But then part B says, find the gradient of the line. So we kind of did that work before, didn't we? And we found out it was 5 over 4. So we can then write our gradient as 5 over 4. Now, the second part of part B says, explain what this gradient represents. And what this gradient represents is the number of cups of water needed for each cup of rice. So we write that down. So the number of cups of water needed per cup of rice. And that answers the second part of part B. Moving on to question 10 now. Question 10 is a circumference question. So the circumference of a circle is 10 meters. Work out the area of this circle. Give your answer in terms of pi. So the first thing here is, what is the formula for the circumference? The formula for the circumference is 2 pi r, where r is the radius. And we're told this is equal to 10. So from here, we can find out what the radius is straight away, can't we? To find the radius, we need to think, how do we get from 2 pi lots of the radius to 1 lot of the radius? And to do that, we need to do the opposite of timesing by 2 pi, which is dividing by 2 pi. So we do that to both sides, and that gets us 10 over 2 pi, which we can simplify to 5 over pi. From here, we know what the radius is, but then we also need to find out the area. The equation of the area is pi r squared, but we know what the radius is now. So we have pi, then we times it by the radius squared, which is 5 over pi squared. And that is equal to pi times by 25 over pi squared, and that simplifies to 25 over pi, since we have 2 lots of pi on the bottom and a pi on the top. So our final answer is 25 over pi meters squared. Moving on to question 11 now. Question 11 is a box plot question. So it says, Alice recorded the number of cars going into a village on each of 80 days. The incomplete table and the incomplete box plot gives information about her results. And we're given a partially filled out table and a partially drawn box plot. So part A says, use the information in the table to complete the box plot. So if we look at the box plot, what's missing? So 3 things are missing here. The lowest value, or the smallest value, the median, and the biggest value. Because here, the lower quartile and upper quartile have been given by this box itself. So what is the smallest or lowest number of cars? We've been told it to be 300. And 300 is here. So that can be one part of our box plot. So we can have a line there. And we can connect that with the box plot itself. But now, what about the median? The median, we're told, is 900. And 900 is here, so we can then draw a line there. And last but not least, we need to find the biggest number, or the largest number. But we haven't been given it straight away, but we've been given the range. What does the range tell us? The range tells us the difference between the smallest value and the largest value. So from there, what we can do is add 1,000 to 300. So it's 1,300. So 1,300 is now the largest number. And that is our box plot completed. But now the second part of part A says, use the information from the box plot to complete the table. So when it comes to the lower quartile, it's this line here. We'll draw a dotted line to extend it. And that is 780. Now looking at the other line that was drawn for us, it goes to 1,200. That is our upper quartile. So 1,200 is our upper quartile. And that's our table filled in. Moving on to part B now, it says, on some of the 80 days, Alice saw fewer than 1,200 cars going into the village. Work out an estimate for the number of days Alice saw fewer than 1,200 cars going into the village. So the first thing that comes to mind is 1,200, that's our upper quartile. But what does our upper quartile mean? So our upper quartile is where all the information to the left of it is 75% of our data. So in other words, the chance is 75% to be less than 1,200. But what are we trying to find 75% of? That's the 80 days that Alice has sort of looked at the results, so 80 days. So the next thing that we need to do is find out what 75% of 80 is, and that's 60 days. So in other words, the estimate is 60. Question 12 says, the straight line L has equation 2y is equal to 3x minus 7. Find an equation of the straight line perpendicular to L that passes through 6, negative 5. So the first thing that we want to do here is find out what the gradient of our straight line L is. So we have 2y is equal to 3x take away 7. But we want to have it in the form y is equal to mx plus c. So to do that, we need to go from 2y to y on its own. But how do we go from 2 lots of something to 1 lot of something? We divide by 2, don't we? So we divide both sides by 2. So then we get 3 over 2x minus 7 over 2. Now from here we can see that our gradient is 3 over 2. But to find the gradient of a line perpendicular to L, we need to look at the negative reciprocal. So what is the negative reciprocal of 3 over 2? It's minus 2 over 3. So in other words, we know our line has a gradient of minus 2 over 3. So we can write y is equal to minus 2 over 3 x plus c. We've also been given the point 6, negative 5, so we can put the value of x and y into our equation. So we have negative 5 is equal to minus 2 over 3 times 6 plus c. So minus 5 is equal to negative 12 over 3 plus c. So then c is equal to minus 5 plus 4 once we simplify the fraction, which gives us negative 1. So our equation of a line is y is equal to minus 2 over 3x minus 1. Looking at question 13. Question 13 says a solid A and solid B are similar. The ratio of the height of solid A to the height of solid B is 2 to 5. The volume of solid A is 12 centimeters cubed. Work out the volume of solid B. So with this question, the key thing is to understand how to deal with ratios. So we have solid A, which is 12 centimeters cubed, its volume. So we need to find out how much bigger the volume of solid B is, and that's what the ratio tells us. So we have a ratio of 2 to 5. So in other words, what we need to do is do 12 times by 5 over 2 to the power 3. And what that gets us is 187.5. By simplifying it, and we get this. So our final answer is 187.5 centimeters cubed. Looking at question 14 now, we need to work out 27 to the power 2 over 3 plus a half to the power negative 3. So let's first take this step by step. So let's first have a look at 27 to the power 2 over 3 and go from there. So the first thing we want to realize is 27, that's equal to 3 times 3 times 3. In other words, 3 to the power 3. So then we can rewrite this as 3 to the power 3 to the power 2 over 3. And whenever we have powers like this, we times the powers together. So we have 3, then we times by 2 over 3, so the 3's cancel out, and we're left with 2 on its own. So in other words, 27 to the power 2 over 3 is equal to 3 to the power 2. So from here, 3 to the power 2, that's just equal to 9, isn't it? So now let's move on to the second part of the question. So we have a half to the power negative 3. So one thing to remember is a half is equal to 2 to the power negative 1. So if we substitute that in, we have 2 to the power negative 1 to the power negative 3. In a similar situation, we times these powers together. So we have 2 to the power 3 because a negative times by a negative makes a positive. And 2 to the power 3 is equal to 8. And if we put both of these together, we have 9 plus 8, which is equal to 17. So 17 is our final answer. Question 15 says, an object falls from rest. Here is the distance time or distance time graph for the distance fallen by the object t seconds after it starts to fall. So the question says, work out an estimate for the gradient of the graph at t is equal to 3. You must show how you got your answer. So in this case, the first thing we need to do, as I've done here, is to actually highlight where t is equal to 3 actually is. And from here, draw a dotted line up to where it meets our line. And what we need to do here is draw a straight line that only goes through that particular point. So try your best to only draw a straight line where it crosses or touches the line at t is equal to 3. And then with that in mind, if we have a closer look at our line, we can find the gradient by doing the rise over the run. And in this case, if we do the rise over the run, we will get something along the lines of around 25, give or take. So 25 is a good approximation or estimate for the gradient. And that would be our final answer there. Moving on to question 16, we're now dealing with a formula. But let's read the question and see what it asks. So at the start of the year n, the population of a species is Pn. At the start of the following year, the population of the species is given by Pn plus 1 is equal to Kpn, where K is a positive constant. The population of the species at the start of year 1 is 8 million. The population of the species at the start of year 2 is 6 million. Work out the population of the species at the start of year 3. So this is a good example of proportions. So in this case, year 2, we had 6 million, and that's equal to a positive constant K, but in this case, the population for year 1 was 8 million. So in other words, we have 6 is equal to 8k. So we can rearrange this to get k on its own, which is 6 over 8, which we can simplify to 3 over 4. Now something to remember is k is a constant, so it doesn't change. So in other words, we can now write Pn plus 1 is equal to 3 over 4 Pn. So now, if we want to find P3, so the population of the species at the start of year 3, this is equal to 3 over 4 times by the population at the start of year 2. So in other words, we have 3 over 4 times by 6. And that would give us 18 over 4, which is equal to 9 over 2, which is equal to 4.5. So the population of the species at the start of year 3 is 4.5 million. Now moving on to part B now, at the start of year 5, the value of k increases by 0.3 to a new constant value. Louise thinks that from the start of year 5, the population of the species would increase year on year. So let's see if this is right. So Currently, our k value is 0.75. So if we added 0.3 to it, our new k value is now 1.05. So now our k value is above 1. So let's see if at the start of year 5, our population would start to increase. So we already know what our population is at the start of year 3, and that is 4.5. So P3 is equal to 4.5. But now what would P4 be equal to? It's equal to 1.05 times by P3, wouldn't it? And in this case, whenever you're timesing something by a number above 1, it would go up, wouldn't it? Then when it comes to P5, we have 1.05 times by P4. And since P4 is bigger than P3, this would also go up, wouldn't it? So Louise is correct, and the main reason why is because 1.05 is greater than 1. So we would see an increase. Now, heading on to question 17, part A, we have a factorized question. So we have a quadratic, don't we? 6x squared minus 5x take away 4. Now to factorize this, there's many different ways you could approach it. But one way to approach it is the following. Look at the coefficients of x squared and the constant. So we have a 6 and a negative 4. Now what we want to do here is times these together, which gets us negative 24. Now think about this middle coefficient here, negative 5, and just write it here. What we want to do now is find two numbers that times together to make negative 24, but add together to make negative 5. And two numbers would be negative 8, and 3. So then, in our brackets, we write 6x squared minus 8, or 6x to be more specific. Then we also write 6x plus 3, and we simplify it down. So then we have 3x take away 4, 2x plus by 1. And that would be the factorized version of the quadratic, and now all we need to do is write it on the dotted line. Amazing. Now moving on to part B, we're asked to solve this inequality now. So when it comes to solving quadratic inequalities, firstly we want to write it in a factorized form, which we've done in part A. So that's one step already done. Now from here we need to find out what the x-intercepts are, so when it reaches the x-axis. And it is x is equal to 4 over 3, and x is equal to negative a half. So we can draw a small little sketch for ourselves. Negative a half is around here, 4 over 3 is around here. And our quadratic would look something like this. But now we want to see when it's less than 0. So in other words, this shaded region here, right? Because it's less than 0 then. As a result, x is greater than negative a half and less than 4 over 3. Looking at question 18 now. Question 18 is a spinner question. So spinner A and spinner B are each spun once. The probability that spinner A lands on red is 1 over 4. The probability that both spinner A and spinner B lands on red is 1 over 24. Work out the probability that one spinner lands on red and the other spinner does not. So, what we can say here is the probability of A spinning on red is 1 over 4. And the probability of A and B spinning on red is 1 over 24. So in other words, what we can do is find out what the probability of B spinning on red is, because the probability of A spinning on red times by the probability of B spinning on red is equal to the probability of A and B spinning on red. So here, the probability of A is 1 over 4. Probability of B is what we want to find out, and that is equal to 1 over 24. So here, to get this unknown value on its own, we divide both sides by 1 over 4, and as a result, that gets us the unknown value of 1 over 6. So now we know what the probability of B spinning on red is, which is 1 over 6. But now we want to find out the probability of one spinning on red and the other not spinning on red. So what we can do here is think, what is the probability of A spinning on red, but then B not spinning on red? And that is 1 over 4 times by 5 over 6, which is equal to 5 over 24. But then we also need to consider the probability of A not spinning on red, but then B spinning on red. And that is equal to 3 over 4 times by 1 over 6, which is equal to 3 over 24. Now all we need to do here is add these two fractions together, which gets us 8 over 24, in other words 1 over 3. Looking at question 19 now, question 19 gives us a graph of a sine function. Now part A tells us use the graph to find estimates for the solutions of sine of x is equal to 0.3. So the first thing we want to think about is 0.3 is around here, isn't it? So in this case, we'll draw a dotted line across and see where we end up. So if we look down here, we're 3 boxes along, but then to get to 90, we've gone 15 boxes along. So 15 boxes is equal to 90 degrees, but we want to only go 3 boxes along. So in other words, divide by 5, right? And 90 divided by 5 is 18. So in other words, our first value is 18 degrees here. But then here, we also need to find out wherever this is. And a nice trick we can use is with the sine function, we can do 180 take away whatever this angle was, which is 18. So that gives us 162. So then we have estimates for the solutions. We have one estimate, which is 18 degrees, and we have a second estimate, which is 162 degrees. X plus 20 is equal to 0 for this range. So with these types of questions, the first thing we want to do is edit the range, or the domain. So instead of x, we're looking at x plus 20 now. So let's edit our range. So then to get from x to x plus 20, we need to add 20 to both ends. So then we have 200 here, and we have negative 160 here. Now from here, what we need to think of is, when is sine equal to 0? And it's equal to 0 when sine is equal to 0, 180, or when it's negative 180. So in other words, x plus 20 equals 0, or is equal to 180, or is equal to negative 180. So let's consider each case. When x is equal to, or when sine is equal to 0, x plus 20 is equal to 0, so then x is equal to negative 20. Is negative 20 in our new domain? It is. So that is one possible value. When x plus 20 is equal to 180, x is equal to 160. Is that in our new domain? It is. So that is another possible value. When x plus 20 is equal to negative 180, what is x equal to? It's equal to negative 200. Is that in our domain? It is not. So negative 200 isn't a possible value. So we're left with the following two values, negative 120, or negative 20, apologies, and 160. Looking at question 20 now, question 20 gives us a triangle, ABC, and we want to find the size of angle ABC. Now here, this is a classic case of the cosine rule, and I'll tell you why. So here, we have a side, we have another side, and we have a third side here. And in many cases, the cosine rule is used when we have this side angle side sandwich. So, do we need to recall the cosine rule? One thing we could do is look at the support or the formula sheets given by the examiners. The great thing about this is the cosine rule has been given here. So here, c squared is 5 root 7 squared, a squared is 10 squared, b squared is 5 squared, and then take away 2, a is 10, b is 5, cos c. Or whichever way around you want to mention a and b, perfectly fine. So from here, 5 root 7 is 25 times 7. 100 squared, or 10 squared is 100. 5 squared is 25, and then we have minus 2 times 5, which is 10. 10 times 10, 100. So we have minus 100 cos c. 25 times 7 is 175. We'll move 100 to the other side. We'll move 25 to the other side. And we're left with negative 100 cos c on the right-hand side. Now 175, take away 100, take away 25, that's 50. And it's now equal to negative 100 cos c. So cos c is equal to negative 50 over 100. In other words, cos c is equal to negative a half. So what is the value of c? Now in this case, because it's a non-calculator, we need to use our knowledge of trig values. So when cos of c is equal to negative a half, the value c is 60 degrees. So c is equal to 60 degrees. But one thing we need to take into account is the angle ABC. It's not an acute angle, it's an obtuse angle. So what other value or degree can cos of c equal negative a half? And that value is 180 take away 60, which is equal to 120 degrees. So our final answer is 120 degrees. On the grid, draw the graph of x squared plus y squared is equal to 169. So here, the first thing we need to think about is, what is this equation of? And it's the equation of a circle. Now the next thing to think about here is, if that's the equation of a circle, how can I find the radius? And all the radius is the square root of whatever that number is. So the square root of 169 is equal to 13. So our radius is 13, somewhere here, somewhere here, somewhere here, and somewhere here. And all we need to do now is very carefully draw a circle to show this. Something like that. So that would be our circle there. Part B asks us to use the graph to find estimates for the solutions of the following simultaneous equations. Now to do that, what we need to look at is what the bottom equation is. So the bottom equation is 2y is equal to 3x. So then y is equal to 3 over 2x. So let's draw y is equal to 3 over 2x on our diagram. And that would look like something like this. So the next thing we want to think about is, what are our solutions? And our solutions are where these two lines, or this circle and this line, intersect. So when we have a look here, what we need to do is see where these values are. So we've got one value around the 7.5 area, and we have another value around the 10 or almost towards the 11 area. So the best thing to do here is to just think sensibly, what are or what is good for an estimation. So if we look very closely, we get some sort of value of around negative 7.4. And then if we look closely here, we get a value of around 10.7. Negative 10.7 to be specific. And since we're dealing with exactly the same on the other side, we would have 7.4 and 10.7 again. So then our two estimated solutions would be negative 7.4, negative 10.7, and 7.4, 10.7. Moving on to the last question. This is a geometric sequence question. So we're told the second term of our geometric sequence is 3 plus by 2 root 2. And then our third is 13 plus 9 root 2. Find the value of the common ratio and give your answer in the form a plus root of b, where a and b are integers. Now in this case, a geometric sequence is where you times by something, some common ratio to get the next term. So what we need to do to get the common ratio is we need to do 13 plus 9 root 2 and divide that by 3 plus 2 root 2. So now from here, we need to do something called rationalizing. So what we need to do here is we need to times by 3, take away 2 root 2, over 3, take away 2 root 2. So in other words, we're just timesing by 1, because anything over itself is equal to 1. So if we expand the top and the bottom, we get 39 take away 26 root 2 plus 27 root 2 take away 18 lots of 2. Then in our denominator, we get 9 take away 6 root 2 plus 6 root 2 take away 4 lots of 2. So then if we look on the bottom, negative 6 root 2, positive 6 root 2 cancel out. So then on the bottom, we're left with 9 take away 8, which is just equal to 1. Then on the top, we've got 39 take away 18 lots of 2. So in other words, we just have 3 plus root 2, because negative 26 root 2 plus 27 root 2 is root 2 on its own. So then we're left with 3 plus root 2 over 1, which is just 3 plus root 2. And there we've reached the end of paper 1. Quite a difficult paper, but with more practice, these questions should start to get a little bit easier. And as always, when it comes to these past papers, if you're ever stuck on a question for a very long time, skip it. If you have spare time at the end of the paper, go back and revisit, try to gain as many marks as you can. Hope you liked today's video. Feel free to like, subscribe and comment if you found it helpful. If you have any questions or any requests for specific past papers you want me to run through, leave them in the comments. And until the next upload, see you later.